Okay, in section 7.4, we're going to look at how we solve what we call a rational equation. So what is a rational equation? A rational equation is an equation that has one or more fractions, and you're going to have a variable in at least one of the denominators. So if you look at these right here, a rational equation, this one would not be a rational equation because it does not have a variable in at least one of the denominators. That's an equation with fractions in it. Okay, the second one, okay, this is a rational equation because it does have one or more fractions. There's two fractions here, and there is a variable in at least one of the denominators. Okay, same thing with C. That is a rational equation. It's got three different fractions, and each of those has a variable. So you always have to have a variable in one of those denominators somewhere. So when you solve a rational equation, this is generally what you're going to do. You're going to determine what values, sometimes there's one value, sometimes there's no values, but sometimes there's more than one value that makes you have a zero denominator. So if you have a zero denominator, a value that makes a denominator to be zero, then that cannot be a solution of the rational equation, so you can't use it. Okay, you want to find the common denominator of all of the fractions. You want to multiply both sides of the equation by that common denominator, and that will clear all of the fractions from the equation. Then solve the resulting equation. The resulting equation will not have fractions, and then you can check the solution. And sometimes your solutions do not check because they might cause a zero denominator. So let's go down to this example here, and let's do a couple of these. Okay, so we're going to solve these rational equations. So both of these are rational equations. They have a variable in one of the denominators. So the first thing we're going to do is we're going to figure out what x can't be equal to. So we just look at the denominators, and you can do this in your head, or you can just take the denominator and set it to 0 and solve the equations. Both of these equations are going to give you the same answer, of course. So we undo the multiplying of 4 by dividing both sides by 4. This is going to result in x being equal to 0. You would get exactly the same thing if you did this. Why am I dividing by 4? I need to be dividing by 2, teacher. Okay, so let's divide by 2, divide by 2. You get the other result, x can't be equal to 0, so it's the same thing. So x cannot be equal to 0. That's kind of an important thing to look at the beginning of the problem is there anything x can't be? Okay. Now, what we're going to do is we're going to multiply both sides of this equation by the common denominator. Okay, so I'm going to write down the original problem as it is, and we're going to focus on these denominators. And the idea is if you had 3, you have 3 over 4x. Okay, it's actually very easy to get rid of that denominator. If you multiply by 4x, then it'll go away. Then you would get 3. You don't have a fraction anymore. You have the other part of the problem, which is 5 over 2x. Well, if you multiply that by 2x, that would also get rid of the denominator. And then if you take the 7/4, if we multiply that by 4, that will also get rid of the denominator. However, you can only multiply by one thing. You can't multiply by each little piece you're trying to get rid of. So what works is if you were looking at your common denominator between 2 and 4, if you write out the multiples of 2 and the multiples of 4, well, they're going to overlap at 4. So that is your least common multiple. That's your common denominator. And we also have to get rid of an x. So what we're going to do is we're going to multiply both sides of this equation by 4 to get rid of 4, 2, and 4. And at the same time, we're going to multiply by x to get rid of the x's. So we have to do this to both sides of this equation, okay? And the key to doing these type of equations is doing this correctly. So I'm going to carefully write the next step. In red, I'm going to put that over 1, and then we're going to multiply by that by 3 over 4x. Okay, on this side, I'm going to do the same thing. I'm going to put that over 1, both of those, and I'm going to do a distributive property. So I've got 4x over 1 multiplied by 5 over 2x minus, and then I'm going to distribute here. So I'm going to have 4x over 1 multiplied by 7 over 4. So you want to multiply by that denominator. Okay, now if you look at these parts of the problem, there's really, 3 parts of this problem. What you need to do is you need to reduce the fractions. Just cancel out what cancels out. What you're going to see here is those go away. That's, and any time you cancel a numerator and denominator, it's really 1. So you really have 1 times 3 over 1 times 1, so that becomes 3. So you don't have that fraction anymore. Okay, you go to the next part. Well, notice the x's divide out. X over x is 1. And then this is 4 over 2, but 4 over 2 is 2. Okay, so you can go ahead and reduce this down to 2 over 1 if you want to. Okay, now if you put this together, we have 2 times 5 or 10 over 1, so that's just going to be 10. Okay, now let me erase this kind of scribbling over here. You can also take this approach if you want to. You can just multiply straight across. So if you did that, you would have this part here would be 12x over 4x. This part here would be 20x over 2x like that. And then this part here would be 28x over 4. And you can do the problem that way if you want to. You'll get the same result. So what I'm going to do on here is notice this. The 4's are going to cancel out there. That's going to leave subtract 7x over 1. 7x over 1, of course, is minus 7x. Now, if you don't want to do the cancellation that way, you can just multiply straight across and reduce. Some students prefer this. Notice if we did that, x's cancel out. 12 divided by 4 is 3, so we get the same thing. Over here, x's cross out. 20 divided by 2 is 10. And over here, 28 divided by 4 is 7, and we're left with an x. So you can do it that way if you prefer to. Now what you have is you have an equation that you can solve. Okay, so it's kind of up to you which side to keep the x on. You could move that to the other side, or the way I'm going to do this is I'm just going to keep the negative 7x where it is, and I don't want the 10 to be there, so I'm going to subtract 10 from both sides. That will give negative 7 is equal to negative 7 times x. Then I can close the deal by dividing both sides by negative 7. And that will leave me x is equal to positive 1 as a solution to this problem then. Okay, so what you're doing is you're getting rid of the fractions. And after you get rid of the fractions, when you get down to this phase right here, then you have a basic equation that you can solve. So we would say the solution set on this problem, we would write that as brace and then 1 like that. Okay, now I'm going to check this over kind of at the side before I do the second problem. So it's important to know how to check. So all we got to do is everywhere we see an x, just plug in a 1, work out the details, and see if this doesn't work. Okay, so let's plug in that 1, and let's see if this works. So what's going to happen is I get 3/4 here is equal to 5 over 2 minus 7 over 4. So I would need to get a common denominator to subtract these two fractions. So if I multiply this by 2 over 2, I'm going to get 3/4 is equal to 10 over 4 minus 7 over 4. And notice that that's going to be correct. So now that you have a common denominator, you keep the measurement. The denominator is the measurement. 10 minus 7 is 3. So you got a right answer to a problem. Okay, so it's important to know how to check your answer when you do an equation. You can always tell you're right. So we know without a doubt that this is our solution set. Okay, very good. Okay, next one. First thing we're going to do is we're going to look just at, we just have this one denominator. So we set that equal to 0, and that automatically tells us that x cannot be 0. So when we solve this equation, we don't want to get 0 for an answer. If we do, we have to throw it out. So what we got to do is we got to figure out how we're going to get rid of the fraction. So I'm going to go ahead and I'm going to write down the original equation. And really, you can look at this like this. Now I'm going to erase this checking here. If you need to pause the video anytime you can, but I'm going to erase this. And what I want to look at is really I only need to get rid of one thing. If you look at this part of the problem right here, the 24 over x, if I multiply that by x, then the x is gone. And that's all I got to get rid of. So what I'm going to do is I'm going to multiply both sides of this equation by just by x. Okay? So I'm going to do a distributive property. I've got x times x would give x to the second. Then I'm going to take this like this, and that's an x over 1, so that would be 24x over x, and then the right side is going to be negative 2x like that. So what that's going to do is the x's are going to divide out. There, x over x is 1. So what we get is the quadratic equation, x to the second minus 24 is equal to negative 2x. All right, now what we have to do on this is when we solve a quadratic equation, we always want to either factor or use the quadratic formula. Completing the square is not something you have to do. So what I'm going to do is move that to this side so I get x squared plus, make sure that sign changes when you move it, plus 2x minus 24 equals 0. Then we're going to solve this equation by factoring. Okay, so the first term would be x and x. The last term would be numbers that multiply to give 24. So I'm just going to go ahead and just write all these down. And then they have to add up to 2x. So 1 and 24 aren't going to add to 2. 2 and 12 isn't right. 3 and 8. 4 and 6 are 2 units apart, so those should be the correct factors. And the way you accomplish this is you have negative 4 plus 6 will be positive 2. So we need to have plus there and a minus there. For factoring, now what we need to do is set each factor equal to 0 and solve each equation, okay, which we can do these in our head if you want to. So you don't have to really show any work. You could add 4 here. So what you're going to get here is one of the solutions looks like it's x equals 4. Okay, then over here you can subtract 6 from both sides. It appears that the other solution is negative 6. Okay, so that's an equation that ended up being quadratic when you solved it. Okay, now it's important to check. I mean, because sometimes these things don't check. So I'm going to go ahead and do this over here. And you don't necessarily have to write this down on your notes, but you do need to know how to do this. So I'm going to plug 4 in. So I'd have 4 minus 24 over 4, and we're going to see if that's equal to negative 2. So that is 4 minus 6. That's equal to negative 2. So we know that that right there is a correct answer. Okay, now I'll try the negative 6. So now I got negative 6 minus 24 over negative 6. We're going to see if that's also equal to negative 2. So this would be negative 6 plus 4, which is equal to negative 2. So that means the solution set on this problem is negative 6 and 4, so we've just proved that that is correct. There are times when one or both of your answers don't check. So when you get an answer to a rational equation, it's pretty important that you take the time to check. Okay, I'm going to go to the next page. And I'm going to work one more out, then I'm going to let you do a few problems. We're going to kind of like do 2 levels of problems here. So this one right here, the first thing is look at your denominators and figure out what x cannot be. And there are times when it's pretty easy to do this in your head. If you can solve these 2 equations, then that's going to tell you what x cannot be. Okay, so over here you could add 4 to both sides. Okay, so if x is 4, you're going to have a 0 denominator. So x cannot be equal to 4. Over here, we could add 7 to both sides. That gives 2x equals 7. Divide by 2 to isolate x. X can also not be equal to 7 over 2. Okay, so that's kind of the first thing you always want to do is figure out what x cannot be equal to. Okay, now what we're going to do is we're going to solve the equation. So I'm just going to write down the original equation, and I'm going to leave a little bit of space on both sides. And the way that I do this is I have to get rid of both of these fractions. Okay, so if I'm going to get rid of x minus 4, then I have no choice but to multiply both sides by x minus 4 in order to make that happen. Okay, that's going to divide that out. If I'm going to get rid of 2x minus 7, then I'm going to also need to multiply by 2x minus 7. And I got to do the same thing to both sides of the equation. Okay, notice if I do that, that's going to divide that out. Now, if you look at what we have here, we are left with this stuff right there. That is our resulting equation after we have canceled. Remember, when you cancel something out, it's a 1. It's a 1 over 1. So we end up here with 2x minus 7 multiplied by 3x plus 1 is equal to 6x plus 5 multiplied by x minus 4. So we have to solve this resulting equation. Okay, in order to do this, we got to FOIL. So you want to go ahead and start foiling. First term, 2x times 3x, 6x the second. Outside term, 2x times positive 1 is positive 2x. Inside term, negative 7 times 3x is negative 21x. Negative 7 times 1 is negative 7. Okay, do the same thing on the right side. Do the FOIL. 6x times x is 6x the second. 6x times negative 4 is negative 24x. Now do your inside term. 5 times x is positive 5x. And then 5 times negative 4 is negative 20. So be very careful when you multiply by FOIL. Make sure all your signs are correct. Okay. Next thing I spot is each side has some like terms. So I'm going to do that. That's going to give me 6x squared minus 19x minus 7 equals 6x squared minus 19x and then minus 20. Okay, so you want to put together those like terms then. Okay, and this is going to be kind of an interesting equation here. What's going to happen is going to be a little unusual. Okay, so now this is a quadratic equation. I know it's quadratic because the highest power is 2. So I have to get one side equal to 0. The simplest way to do that is to move everything from the right side to the left side. So I'm going to bring straight down the 6x squared minus 19x minus 7. Now when I bring everything over, all of the signs will change. Minus 6 plus 19 plus 20 equals 0. Okay? And then notice what happens on this. That goes to 0, that goes to 0, and then you get this. You get negative 7 plus 20 is 13 equals 0. What in the world happened? Well, we got something that we call in mathematics, we call this a contradiction. Okay, we got a false statement. If all the variables cancel and you get a false statement, that means the solution is the empty set. So there is no solution on this. So what we say is we usually just write empty set. Okay? And that'll happen sometimes. There are times when an equation doesn't have a solution. It turns out that no matter what you plug in for x in this equation, both sides of the equation will never be the same. So that's weird. That can happen though. Okay, all right, so pause the video if you need to look through that and think about that a little bit or get anything written down. Otherwise, you can go ahead and move down to the bottom of the page, and we're going to do the next 3 problems. So do problems 1, 2, and 3. And go ahead and pause the video now, and then when you're done, resume the video so you can see if you got the right answers. Okay, so go ahead and check and see what you got on this. The answer to number 1, x cannot be 0. 0 is what makes the denominator 0. And then if you solve the equation, you would have got a solution set of -3. That does check, and I'll show you in a minute kind of how that checks on a calculator. So if you kind of look through what I did, the common denominator on this is 45x. All of these numbers divide into 45. 3 divides into 45 15 times. 5 divides into 45 9 times. So you want to multiply by 45x. Okay, that's the smallest number you use. You can use other numbers too. You just have to find a number that all 3 of those numbers divide into. They would all divide into 90 also. They would all divide into 135. But your work's easier if you figure out the smallest number on that. Okay, students kind of have a tendency to want to just always multiply these things out. So I mean, if you did that and took your calculator and actually did that, let me show you what would happen. If you did 3 times 5 times 45, you would get 675. And if you multiply by 675x, you'd still get the same answer. It's just not worth it. Okay, find the smallest number they all divide into. That takes a little bit of arithmetical skill, I think, to do that. Okay, so ultimately, you want to kind of check on your paper. Ultimately, you would have got down to this stage here. After you got rid of your fractions, you should have ended up with the equation 30 equals 54 plus 8x. Then it's pretty standard from there. Okay, now what I did is I just took the answer and plugged it back in. I do plug it back into the original equation. I'm going to have 2 over 3 times -3 equals 6 over 5 times -3 plus 8 over 45. So if you work out the details, you can kind of see how the arithmetic goes. And if you want to, you could do this on your calculator. You could go 2 divided by -9 plus, or no, 2 divided by -9. It's going to give you that. Now the right side, you could go 6 divided by -16 plus 8 divided by 45, and you'll get the same thing. Oh, what in the world did I do? I must have typed something in wrong there. That's a 15. I'm sorry, that right there is a 15. So if you do 6 divided by -15 plus 8 over 45, then it checks out. Both sides turn out to be -0.2 repeating 2's. So, I mean, you can use your calculator to help you check if you want to. Okay, number 2, x can't be 0, and the solutions are -7 and 3. So what I multiplied by was 4x. 4x will get rid of both the 4x and the 4. So after you multiply by that common denominator, you should have got this quadratic equation. X squared subtract 21 equals -4x. And you move the 4x the other side, you're going to get one side equals 0. Solve by factoring. So you got to factor the trinomial. That's how you'll get the 2 answers. And both of these answers check. I mean, you can run through that if you want to, or at least, or write that down if you want to. You didn't have to check on these problems, but it's something that you want to be aware of. Okay, so pause the video if you need to correct anything or look over anything I did on this. And then we'll go to the next example, then that will end the recording. Okay, next page. You should have got the solution sets -11. X cannot be -3 and -2. So you're going to set each denominator equal to 0 to find what the denominators cannot be. And with this one, really what you have to do is you have to multiply both sides of the equation by x plus 3 and x plus 2. That way it'll get rid of both denominators. Then you end up with this. This is the equation you end up with. Then it's a matter of FOIL. Got to check that you did the FOIL. Collect like terms. and get one side equal to 0. If you solve that equation, ultimately you end up solving the equation negative 2x minus 22 equals 0. That will give you x equals negative 11. Okay, and then here's the checking. You can look over the checking. That verifies that that's the right answer. Okay, so I'm going to go ahead and stop the video here. This will be the first type of rational equation you want to learn how to do. The second part of the video, we'll look at a little bit different situation. All right, so I hope this helps you to be successful with solving these kind of problems.